Okay, example 2 here wants us to prove the triangle angle sum theorem. So the triangle angle sum theorem said the three angles of the triangle add up to 180. So given any triangle ABC, the measure of the three angles of that triangle are going to add up to 180 degrees. We're going to do this as a paragraph proof. So the first thing we're going to do is we're going to let, DE, see how well we can write, be parallel we'll say parallel to AB. Well, we don't need to write all that. DE be parallel to AB. So we're going to draw a line in here that's parallel to AB that goes through point C. Okay, so we're going to draw on a line here. It wasn't the best line I've ever drawn. Okay, that's going to be parallel to AB. Okay, we're going to say let's draw that line in so that it's parallel to AB. Okay, and then we can call these other angles that are formed here angle 4 and angle 5. Okay, if we notice angle 4, angle 3, and angle 5 add up to a straight line. So we know that by the definition of a straight angle or a straight line, so by the definition of a straight line or straight angle, straight angle, right? The measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is going to equal 180. Right, so a straight angle adds up to 180, right? If you have angles adding up to a straight line or forming a straight angle, those are going to add up to 180. So angle 4, 3, and 5 are going to add up to 180 degrees here. Okay. We also notice that since our lines are parallel, we can use our alternate interior, alternate exterior, corresponding angle theorem, or same side interior angle theorem. And we notice here we have some alternate interior angles. So if AC was your transversal, if I could draw a straight line, it would really help. Okay, so that means angle 1 here and angle 4 are alternate interior angles. So since the lines are parallel, the alternate interior angle theorem, so by the alternate interior angle theorem, all right, we know that angle 1 is congruent to angle 4. And then if we have we use this transversal, we know that 2 is going to be congruent to 5. So, and by the alternate interior angle theorem, angle 2 is congruent to angle 5. Okay. If we know the angles are congruent, we know their measures are going to be equal. So we can say then by the definition of congruent, so by the definition of congruent, right, we can say the measure of angle 1 equals the measure of angle 4. And likewise, we can say the measure of angle 2 equals the measure of angle 5. Right? So just to recap, we drew in a parallel line. So we drew in a line that was parallel to AB. We just constructed a line that was parallel to AB. And we created angles 4 and 5. And then the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is equal to 180 because they form a straight line. They form a straight angle. Okay, so by the definition of a straight angle, those three angles add up to 180. Since our lines are parallel, we constructed a parallel line. Our alternate interior angles are going to be congruent by the alternate interior angle theorem, which says if the lines are parallel, then your alternate interior angles are congruent. So angle 1 and 4 are congruent, and 2 and 5 are congruent. And then by the definition of congruent, we know their angle measures equal each other. Okay. And we can now substitute into our equation here. So instead of the measure of angle 4, right, we know measure of angle 1 equals the measure of angle 4. So we can substitute that in there. We know the measure of angle 2 equals the measure of angle 5, so we can substitute that in for the measure of angle 5. So if we do that there, we can say the measure of angle 1, right, plus the measure of angle 3, plus the measure of angle 2 equals 180. Right, and what we're doing there is substitution, so that should have been by substitution. Substitution. Okay, so we're replacing measure of angle 4 with the measure of angle 1, and replacing the measure of angle 5 with the measure of angle 2. Okay, and then for me, that's good enough. Obviously, you can rearrange these, but if we want to add that last step, we would say by the commutative property of addition. I hope it's the commutative property, otherwise I'll be wrong. I'm pretty sure it's commutative though. By commutative property, right, we can just rearrange those numbers, right? So measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 1. Whoops. I don't think you want to look at me any bigger than you have to. Equals 180. Okay, and that is what we were trying to prove. All right, we're trying to start with triangle ABC and then prove that the measure of the three angles of the triangle added up to 180. So the first thing we did is we constructed a parallel line. Right, and we noticed these three angles here added up to 180. And since we had alternate interior, 1 was equal to 4 and 2 was equal to 3. The measure of the angles were equal. And so 1 plus 2 plus 3 is going to be 180. With the measure of angles, 1, 2, and 3 are going to add up to 180.